Hi, so today I'm going to go over tables. There's so much to cover with tables, so let's jump right in. Before I get into the CL with tables, let's take a look at how they're set up in Desmos. It's always row number and then column number written like a point on a coordinate plane. So I have an example with many different cells labeled here. This one would be row 1, column 1. This would be row 1, column 2. Row 1, column 3, so on and so forth. That's important for when you're writing CL. But before we write CL, I just want to tell you a few other things about tables that I find important. So let's say that we wanted to write something down here that was a word like integer. INT. I haven't even gotten past the T, and already I have an integral symbol. And that's because INT in the math type that Desmos uses means integral as a shortcut. And I cannot type it faster and make it work. It just kind of makes an integral with part of a word. So if that happens to you and you really need the word there, just format it as text. And then integer is easy to type. You can add columns on whatever side that you need. You can add rows. And if I go to preview, you can see that this table is of fixed length and width. But I cannot, in this mode, I cannot add the rows or the columns. So if you need to have students be able to add, then you're going to change the checkbox here, allowing students to add rows. But if you want it a fixed length, then you need to build it ahead of time. And that might just be you pressing enter a few times to make sure that there's enough rows, or adding columns if you need columns. All right, let's jump into CL. In this example, students are to look at the pattern here, count how many squares are used in the first step, and record it here. So their first answer here would be 4. And then they would answer 7, 10, and continuing that pattern, 13 and 16. And as you can see right now on the teacher dashboard, it's just a dot, which indicates that the teacher needs to look at this slide to see if it's correct or not, because the computer doesn't have enough information to figure that out. So what we want to do is we want to put the CL in so that the computer can figure it out and save us some time on a question like this. First off, this component, the sketch component, is not going to be evaluated. So we're going to start off by making sure to write read only true. If you forget it and you're in the habit of previewing after you've written the CL, which I highly suggest that you do, you can check that little dot up there and it'll stay a dot, even after adding the CL for this table. So at that point, you go back and you look and you add in the read only true. So we're going to go into the CL for the table. And we're going to start off just like I've done on other components, like the math inputs. We've used a check variable. Check will check if this is true. And if it's true, then we're going to say bring that into the correct sync and tell the computer that it's correct if it passes check. So for check, we are going to say that in this component, which is the table component that we're in right now, we want to check if the cell number, the numeric value, for different spots within the table are set up properly. So like this first one, let's do cell 1, 2 is the first cell that students are going to write in. I'll go back here. This one right here is cell 1, 2 because it's row 1, which this whole thing is row 1. And then it's the second column over, so 1, 2. And they should have an answer 4 in there. So we want that to equal 4. But we don't want to only check that first cell. We want to check all of the spots that the students are going to enter. So we're going to say this cell cell numeric value. And I'm going to need a few of these, so I'm just going to copy this. All right, for 2-2, 3-2, 4-2, 5-2. All right, so for this, it was 4, 7, 10, 13, and 16. And I forgot to put the and in here, so that's why it's giving me a message. If you do get an error message, you can take a look at it, and sometimes it's clear enough where you can figure it out. Sometimes you might just have to like go back to an example of code that's already written to figure out what it is that's throwing yours off. So this is the part at the end where I'm just saying, if it passes check, then I want you to say that this question is correct. So we're going to go back here, preview, and enter in these values, and it marks it correct. And if I'm missing even just one of them, it marks the entire thing wrong. So just know that when you're checking your student dashboard, that the student might be extremely close, but it's either going to say right or wrong. It's not going to get like partway there with this CL. All right, let's go over this one as well. This one's asking students to create a frequency table given the data. The data is showing up both here, but also over here on the Sketchpad. And that's just nice for students to be able to cross things off, especially because we're not using paper and pencil with Desmos necessarily. And even if they are copying from this list down to a piece of paper and then crossing off, they can easily miss a number. It just sets it up nicely. So one thing that I don't love about this table is that if I want them to put the numbers 2 and then 3 and then 4 and then 5 going down the number column, they can put 2, but they can't expand the table to make it bigger to put the rest in. So I have one of two choices. I can either build the table ahead of time to make it the proper size, or I can let students have the ability to size it the way that they want. I'll show you the building themselves by checking this box, but just to mention, if a student does this, which is how I'm going to program it, then their answers should match with mine. But if a student does this, then everything gets kind of shifted down, even if they have the frequency of 0 in here. Everything's shifted to a new spot and that their answers will not match with mine. So be really careful with allowing students to build their own table and also programming a correctness value for it. Caution there. But we'll do it here just to show how it works. All right, so pretty much the same thing that we've done before. Let's go right in and we'll do check. So this cell content, now we want to do cell content of 1, 1 should be 2. And this cell numeric value, that's what I'm doing wrong. And numeric value. Content is more of like an algebraic expression. 1, 1. I'm just going down the column first. 3, 1. For the cell numeric value of 4, 1 should be 5. All right, and then I'm going to go to do the frequencies. So that's going to be 2, 1, and 2 occurred once. And this would be, I messed up already. This is 1, 2. This should be 2, 2. And that there was 4 of them. This is going to be 3, 2. I often will, instead of doing row column, I'll do column row by accident, and I don't catch it myself, and that usually, and then I have to go back and fix my errors once I know that my code is not working, and that can be a bit frustrating. So that's just, I guess, a word of warning for you folks to watch out for the mistake that I make constantly. All right, so this should work if we go here and we do 2, 3, 4, 5, and then there's 1, and then 4, and then 1, and then 3, and we're getting the dot. But if I go back even one spot, we get the X. So we know something's working properly. And so if you haven't figured it out, the thing that I like to just keep emphasizing is we've added correctness check here, but we didn't even consider this. So we want to go into the CL here, just like our other example, and write read only true. So that gets read as being correct, and then it checks over here for correctness. And 1, 4, 1, 3, and now we get the check mark on the teacher dashboard if everything's correct. Again, if that student does like a 0, 1, and then afterwards 2, 3, 4, 5, and then over here 0, 0, 1, 4, 1, 3, technically it's correct, but the computer's not going to mark it correct because all the cells are jumbled out of place and don't align with what I've set. The other thing that I want to show here is just how flexible this term check is that I'm using. So you don't need to always call it check, and you might need to name it different things for different reasons. So let's say that in this table, we're going to call this the X and this the Y, just to kind of keep it simple. So I could put check X, and over here write check Y, and then underneath correct, I would just say that both the check X and the check Y need to be correct. If both this one passes and this one passes, then it's correct. And that's really up to you, depending on what you're coding and when and why. You might need to name different things at different spots. So just keep that in mind. All right, so I'm going to stop the video here, but I'm going to cover a lot more in tables in another video. And it gets quite a bit more difficult in the next video. All right, take care.